Okay, so we kind of introduced the idea of a matrix and how we can use it to solve an equation or a system of equations, I should say. So let's talk about row echelon form and reduced row echelon form. So what we saw in the example we did in the last video, where we got to the end, and we can come up here. So here we have this one where we had the zeros down here. This would be a row echelon form. Um, and so the rules for the row echelon form, the first non-zero number in any row, and maybe not, maybe let's see, that was almost, so we almost row echelon form. But the first non-zero number in each row from left to right is a 1. It's called the leading entry. The leading entry in each row to the right of that 1, or leading entry in each row is to the right of the leading entry in the row immediately above it. All rows consisting entirely of zeros are at the bottom. So basically what that means, let's go back up to this one. So this one's almost row echelon form. We would need that one to be a 1. So we would just need to divide this row by -3 and divide this one by -1 to get this to row echelon form. But basically, if this is a leading entry, and let's go ahead and do that. So let's we'll just kind of put this one right here real concisely. So divide this one by -3. So we get 1, we get -5/3, and then we get 2. And then divide this one by -1. So we get 1, 0, 0, 1, 3. So now we're in row echelon form. And so all row echelon form, what you want to look for is you want to have the first non-zero number in the row to be as 1. And then if you come, so like this one is a 1, which means that below this, the next leading entry has to be after this one. So in other words, this one, if this is a 1, we're not in row echelon form. So basically any leading entry has to have zeros below it in that column. So the leading entries have to be moving to the right. And the leading entry has to be a 1. So that's row echelon form. And then we have what's called reduced row echelon form. And that's row echelon form, except then wherever we have a leading entry, every other number in that column has to be a 0. So if we go back up to this one, to make this one reduced row echelon form, these 3 we'd have to make to be 0. So you just have 1, the leading entry, have zeros for the rest of the entries in the column. That one has a leading entry. So these two would, first and third row would need to be zeros. Here's our leading entry here. So then the first and the second row here would have to be a 0. So that's the difference between row echelon and reduced row echelon. So let's look at this one. This is not in row echelon form because this one leading entry should be up there. So if this is a 1, this would need to be well, it wouldn't even work that way. This one has to be a 1, and then the rest have to be zeros, and the leading entries are not, in this case, going to the right. They're going up, down, over, all over the place. So this one is in row echelon form. So we have the leading entry here is a 1. Then the next leading entry is in the third column. Moving down, the next leading entry is in the fourth column. And then this one is all zeros, which is at the bottom, which is where it should be. Then this one is in reduced row echelon form. We have the same leading entries in the same spots. And now any leading entry, so that column is all zeros except for that leading entry. The third column is all zeros except for that leading entry. Fourth column is all zeros except for that leading entry. So this takes a little bit of practice. It's hard to explain without seeing, you need to see a lot of examples. The more examples you see of what is and what isn't, the easier it is, but kind of get this idea where if you circle the leading entries they're moving down and to the right. And then in reduced echelon form, any leading entry has all zeros in the column besides that leading entry. All right. So to get row echelon form for a 3x4 matrix, this is basically what we were looking at with the example we did in the earlier video. So you want to get zeros in the second and third row. Have a 1 here, so you divide that row. If say this is a 2 originally, you divide this row by 2 so that that number becomes a 1. Then after you get these two to be 0, you want to work on the second column and get that one to be 0. And then after that, you want to get that one to be, that leading entry to be a 1. And you divide whatever number would be here, you divide that row by that number, and then that gives you a 1 in that leading entry. So then you're in row echelon form, and then it's fairly easy to go and back substitute to solve the equation. Okay, so this is using a method called Gaussian elimination. So Carl Gauss was a mathematician, I believe in the 1800s, and he kind of pioneered a lot of things in math, and this is one of them. So the steps are basically what we did in the example in the last video. So write the augmented matrix, use the row operations to get to row echelon form, and then you back substitute to get the solution for each of the variables. So let's do another example using Gaussian elimination. And so the first step we will do is to write the augmented matrix. So let's do that. So we have 4, 8, -4, 4, 3, 8, 5, -11, -2, 1, 12, -17. And so the first thing we notice, obviously, if we're doing Gaussian elimination, we need ones kind of going down like this, hopefully, if that works out. If it doesn't work out and we end up with all zeros, that's okay too. But this one probably needs to be a 1. So we're in, and plus there's a common factor here. So even just kind of for convenience, it'd be a good idea to divide this row by 4. So we get 1, 2, -1, 1. And then we'll leave these 2 rows the same. All right. And then now we want to get these 2 entries to be 0. So make those 2 entries be 0. We're going to do that. We multiply this one by -3 and add it to row 2. So -3 times row 1, and then add it to row 2. And I would suggest we're going to work with 2 rows. We're going to adjust row 2 and we're going to adjust row 3. But I would suggest just work on row 2 for now and then work on row 3. So -3 times 1 plus 3 would give us 0. -3 times 2 plus 8 would give us 2. -3 times -1 plus 5 would give us 8. -3 times 1 minus 11 would give us -14. And then we're going to do a similar thing to get a 0 instead of that -2. So we're going to multiply this row by 2 and then add it to row 3. So 2 times 1 minus 2 would be 0. 2 times 2 plus 1 would give us a 5. 2 times -1 plus 12 would give us a 10. And then 2 times 1 minus 17 would give us a -15. All right, so then next goal is to get a 1 here and a 0 here. So we're going to leave row 1 by itself. We're going to leave it alone. Let's divide this row by -2 or by +2. So we get 1, 4, -7. And then let's just divide this one by 5 for now, and then we'll adjust it when we get to the next line or the next step. So now we want to get on that third row, we want to get a 0 here. So we can add or subtract 2 minus 3 or 3 minus 2. It doesn't really matter. So let's do 2 minus 3, and that will be our new row 3. So we're going to leave the first two rows alone, and then we have 0 minus 0, we have 1 minus 1, 4 minus 2, and -7 minus -3, which will give us -4. And then to get all the way to row echelon form, we need a 1 there. So we're going to divide the third row by 2. Leave the first two rows alone, and then we get 0, 0, 1, -2 on the third row. And so now we can do a back substitution. So we have z equals -2. We can plug back substitute. So we have y plus 4z equals -7. Plug in the -2 for the z. So y plus 4 times -2 equals -7. And so that gives us y equals 1. And then back substitute both of those into the first row. So x plus 2y minus z equals 1. So x plus 2 times 1 minus -2 equals 1. So we have 2 plus 2, 4, and then 1, bring it over, so 1 minus 4, so x is -3. So our ordered triple is -3, 1, -2. And that would be our equation. Okay, so we'll stop here and then we'll work on more examples in the next one.